Hello. Welcome to my channel. In this video we are going to talk about the equation of a circle in a Cartesian coordinate system. Let's start with the definition. That is the following. The circle is the locus of points equidistant from a point called center. The distance of a point on the circle from the center is called radius. If we choose a certain point of coordinates xc and yc as center, and we choose r as radius, the circle is formed by all points that are distant r from the point C. To find the equation of a circle of radius r, we write the distance between C and a generic point of coordinates x and y, and we set it equal to r. We use the formula for distance of two generic points, and we get square root of the sum of x minus xc squared and y minus yc squared equal to r. We square both members of the equation, and we obtain x minus xc squared plus y minus yc squared equals r squared. We work out the binomial squares. Then we bring the r squared term to the other side. In this way we have obtained the general equation of a circle in the form x squared plus y squared plus alpha times x plus beta times y plus gamma equals 0. We can see how much do the parameters worth. With alpha equals minus 2 times xc, beta equals minus 2 times yc, and gamma equals xc squared plus yc squared minus r squared. So if we have the coordinates of the center and the value of radius, we can write the first equation. That is the canonical equation of a circle. Then calculating the coefficients alpha, beta and gamma, we can write the second equation. That is named general equation of a circle. Viceversa. If we have the general equation, therefore we know alpha, beta and gamma, and we want to write the canonical equation, we have to invert the three equations. We get xc equals minus alpha over 2, yc equals minus beta over 2, and r equals square root of alpha quarters squared plus beta quarters squared minus gamma. We have seen the canonical equation of a circle, the general equation, and how to go from one to the other. Now we want to prove an important theorem of Euclidean geometry that assures us that only one circle passes through three non-aligned points. Therefore it is also possible to write the equation of a circle, knowing the coordinates of 3 points belonging to it. Let's prove the theorem. We have three non-aligned points A, B and C. Non-aligned means that they do not belong to the same straight line. Like the points in figure, we draw the segment joining A and B. Then we know that the line perpendicular to the segment that passes through its midpoint is the axis of the segment. Therefore every point of this line is equidistant from the points A and B. In the animation you can see how moving the point along the line, the distance AF is always equal to the distance BF. Then we draw the axis even for the segment BC, and every point of this axis is equidistant from B and C. Knowing that the point A, B and C are non-aligned, the two axes are not parallel, so they meet each other at a certain point that we call O. This point belongs to both axes. Therefore it is equidistant from A and B. But it is also equidistant from B and C. So we have found out a point equidistant from the 3 points. And OA that is equal to OB and OC is the radius of the circle we are looking for. The point O is the only point with such a property. You can't find another one that is equidistant from the 3 points. So O is the center of the only circle that passes through A, B and C. If we want to write the equation of the circle, starting from the coordinates of 3 points belonging to it, We can substitute the coordinates of the 3 points in the general equation. In this way we get a system of 3 equations in 3 unknowns. And when we solve it we obtain the values of alpha, beta and gamma. For example, the circle in figure passes through the points A of coordinates 0, 3, the point B of coordinates 3, 6, and the point C of coordinates 3 plus 2 times square root of 2 and 4. We write the system. Then we isolate the variable gamma from the first equation. Now we substitute it in the other 2 equations. We have obtained in this way a system of 2 equations in 2 unknowns. We do some calculations. And the 2 equations are 3 times alpha plus 3 times beta plus 36 equals 0. And alpha times 3 plus 2 times square root of 2. Plus beta plus 24 plus 12 times square root of 2 equals 0. From the first equation we can isolate beta. And substitute it in the other equation. Again we do some calculations. And we arrive to the equation 2 times alpha plus 12 equals 0. Therefore alpha equals minus 6. Beta is equal to minus alpha minus 12. That is minus 6. Eventually gamma is minus 9 minus 3 times beta. That is worth 9. We have alpha equals minus 6. Beta equals minus 6 and gamma equals 9. So the equation of the circle, in the general form, is x squared plus y squared minus 6 times x minus 6 times y plus 9 equals 0. If we want to write the canonical equation, we apply the formulas for xc, yc and r that we have proven previously. The canonical equation in our case is x minus 3 squared plus y minus 3 squared equals 9. Well, this video is over. If you like my videos, you can subscribe to the channel. See you soon with another video. Bye.